Good morning, everyone. Today we are in the third class of coastal geomorphology, or the landform formed by different coastal processes. Previously, we learned about the different coastal processes and the effect of those coastal processes in the erosion of coastal rocks and thereby formed different kinds of landforms. So today, in continuation of the coastal processes, we are going to learn how the coastal sediments are transported and how they deposited and form different landforms. দেখতে পাচ্ছিস তো স্ক্রিনটা?
হ্যাঁ স্যার।
ঠিক আছে। So firstly, how the sediments those are eroded and um, applied in the coastal areas by the rivers, how they transport in the coastal areas, how the different uh, marine and non-marine processes are acting on the sediments transported and eroded into the coastal areas, and the activity of waves or tides, uh, how they move those sediments into different places. So activity along the shoreline, along the coastline, can be uh, divided or can be of two types by which the sediments can be transported along the coast. The first type is the long, and the second one is rip current. In longshore current or longshore drift, what happens that in most cases or in most of the places of the coastal areas of the world, the swash, that is the incoming wave coming to the land areas, that fall or that hit the land area at an angle. And we previously came to know that this inclination or incoming wave hitting the land area at an angle, that is the swash hits at an angle, is mainly because of the local topography, local subsurface elevation difference, due to which the incoming wave refracted, which is known as wave refraction, and thereby the incoming wave or swash hits at different angle at different places along the coast. So in almost all the coastal areas, the incoming wave or the swash hits the uh, coastal landmass at an angle. But after approaching the most inland part of the coastal area, when this wave goes back to against the um, or this wave goes back due to the action of gravity towards the downslope areas, that is towards the offshore part as backwash, then this backwash occurs at exactly perpendicular to the shoreline, that is exactly 90 degree with respect to the coastline. So there creates a angular fashion of swash and backwash. Swash coming at an angle with the shoreline, but backwash goes back into the offshore part at exactly 90 degree or at perpendicular to the shoreline. So now if we consider a sediment grain which is transported by the swash wave to the uh, land areas, so that sediment grain is transported along with the wave in an angular fashion and hits the shoreline, hits the coastal areas. Now when backwash goes back to the offshore part, that will move 90 degree or exactly perpendicular to the shoreline. So in this way, in repeated swash and backwash, a grain basically moves parallel to the shoreline. So this is the net movement of the grain. And you can see that this net movement occurs exactly parallel to the shoreline or parallel to the coastal area. So this type of movement is or this type of movement as occur along the shore, that is parallel to the shoreline. So this type of movement is known as longshore current or longshore drift, and often it is also known as beach drift. So in this process, because of this zigzag path of swash and backwash, the net movement of any grain occurs parallel to the shoreline. The second type of sediment transport is known as rip current. These are the strong localized currents. Uh, Mainly these are the backwashes when swash comes to the shore areas or coastal areas and they goes back. During this backwash, sometimes it is observed that this backwash marine water is not uniformly goes back to the ocean. Rather than going as an apron like the swash came, the backwash moves along some uh, narrow areas or narrow channels, and within these narrow channels these are the depressed area, and thereby erosion is occurring in there. So rather by going as a apron to the offshore part, these are moving, the backwash is moving through some narrow straits, and this current is also occurring perpendicular to the shoreline, and this current is known as rip current. Now the interesting thing is that as most of the backwash water is gathering within these narrow straits, so this rip current water has immense uh, water content compared to these areas. The water content here is much higher, and it is of strong bottom current velocity. So often it is hard that in the coastal areas people are trapped in the rip current. So because of this high amount of water, and as they are moving downslope in higher velocity as bottom current, so peoples when act or play in these coastal areas, if they fall in this rip current, so due to the strong velocity of this bottom water rip current, they are dislodging from their positions. They are not stable in their positions, so they are uh, sometimes they drowned within the water body and make it some accident happens. So these are the rip currents. These are the strong localized narrow current um, which moves away from the shoreline and often occur perpendicular to the shoreline. So as these are the maximum water is flowing within these channels, so obviously in the surrounding areas, these are this becomes little elevated part and often forms a little raised area compared to this portion. So this part is much eroded and forms a channel like pattern or channel like shape. Now coming to the coastal landforms formed by sediment depositions. So as I already told you that in the coastal areas, most of the sediments are supplied through rivers. Rivers erode in the far inland. They transport those materials and deposit it in the marine water when they meets with the ocean. Now these sediments are the main source in the coastal areas. Apart from it, apart from these, in some cases where the coastal area occupies some rocky surfaces or rocky landmasses, then due to the action of wave and action of tide, the coastal area itself suffers erosion and thereby produce some uh, sedimentary particles or sedimentary fragments, and they are repeatedly worked out by the coastal processes. So these sediments are repeatedly worked out by the waves and tides and other coastal processes. They are transported from one place to another along the coast, and when the sediments are far are much higher, that means the process which acting on the coastal areas, they are not able to move them from one place to another. That is, there is not sufficient energy. Then only the sediment particles are dumped or deposited in a place and thereby formed different kinds of landforms. Now, due to the deposition of coastal processes in the coastal areas, mainly three kinds of landforms are found to occur: the beach, peats, and bars. Now, beaches are the narrow straits found along the coastal areas, and it is the land or it is the depositional landform which basically separates or which marks the boundary between the land part and the oceanic part. Now, the beaches are mainly made up of the eroded material that has been transported elsewhere from the inland parts, and for these to occur, the waves must have a limited energy so that they cannot they cannot work out on those beaches, on those eroded fragments, on those sediments. Rather, they will be deposited in the coastal areas to form a narrow strait of land, which we called as beach. Now, beach cannot form in all conditions. This narrow strait of landmass, which we call beach, that can only form where the waves are constructive. That is, in those areas only where deposition is the main process rather than erosion. In those areas where erosion is dominant, there we cannot expect or there we cannot get any kind of beach deposition. But in case of constructive waves only, they are built up beaches. Now, in most of the areas of the world, we found that the beaches are made up of sand particles that we call as sandy beaches. So these are the places where the regional slope or general slope of the landform is generally very low to gentle. So in those cases, sandy beaches are formed, but in some cases, it was found that the beaches are made up of pebbles and cobbles. So these pebbly beaches are also found, and these kinds of beaches are generally formed where the source rock from which this pebble fragmented and came to the coastal areas, they are very near to the coast, and often they occur as cliff in the coastal areas. So in those cliff sections, regular waves and tidal currents hit those cliffs and thereby eroded, and these eroded fragments regularly worked out by the wave and formed pebbles and deposited in the coastal areas, so thereby formed pebbly beaches. Now, the cross section or cross profile, if we move from land area to the marine area across the beach, then we get a cross profile of the beach, which is called beach profile. Now, as we learn that beach is mainly formed where the wave activity is dominant. So beach is the product of wave activity, but in almost all the coastal areas, the coastal area is not only suffering the activity of wave, but it is also have some tidal activity. So almost each and every coastal area of the world is somehow affected both by the wave and tidal activity. So depending on these two factors, the all the beach areas, they may be divided into three types. This is mainly based on the relative tidal range. So that means where the tidal activity is maximum, uh, microtidal, mesotidal, and macrotidal. Uh, on these basis, these beaches are actually uh, divided or grouped into three types. The first one, that is the wave dominated. So you can estimate that this should be the microtidal region where tidal activity is very minimum. Second one is tide modified, and third type is tide dominated. So this should be the macrotidal region where the tidal activity is maximum. And depending on the relative tide range, that is abbreviated as RTR, uh, which is basically a ratio of tidal range divided by the wave height of the breaker, that is the average breaker wave height. So depending on this ratio, which is called relative tide range, the beaches can be divided into three types, as I already told you. So when the RTR value is less than 3, beaches are tide dominated. That is, tide activity is maximum in the coastal areas. When RTR value is greater than 3 but less than 15, it is tide modified. That means that the beach area is mainly the product of wave, but some kinds of tidal activity is also modifying the deposition formed due to wave activity. And the last type, where the RTR is greater than 15, then the beach is tide dominated. That means wave processes or the activity of wave found minimum in these beaches. Now, if we look at the beach profile that I already told, that is the across section from land part to the marine part, we can see that the beach is basically formed by two parts. One is the backshore part, another is the foreshore part. So the foreshore part is that portion of the beach which is seaward part, and this portion regularly suffers or regularly face the swash and backwash um, activity. So it is the portion of mean low tide level to mean high tide level. So uh, these areas are mostly uh, composed of ill sorted sand, and uh, they are they are very wet. That means the pore spaces within the sand are uh, full of water molecules, and often it is found that the sedimentary particles in the foreshore areas, they are uh, not only ill sorted but they are also coarse grained. and they also contains different marine organisms, hard parts, and mostly fragmented parts. So this is the area which regularly face swash and backwash. That is the wave activity. So all the stratas, all the sedimentary depositions in these foreshore areas, they show a general inclination towards the open marine. Now, the sediments which are deposited in the foreshore areas during the high tide, these sediments are pushed far towards the inland areas and they deposited in this portion, which is a raised area that separates the backshore part from the foreshore part. This portion is known as barm. Beyond barm, in the far inland part is the backshore part. Now, this backshore part is the portion marked by the end of foreshore, and in the inland part, it is bounded or it is up to that level where during storm activity the swash will affect the land areas. So in normal condition, in fair weather condition during tide, the activity of tide is mostly occurring or occurs up to the foreshore areas. But during storm activity, during high energy condition, when the wave amplitude is much higher, then they inundate the more inland part, and that will extend up to this portion, which is the uh, landward limit of backshore. So up to that portion where the activity of storm is found to occur. So in most of the cases, as you can understand, that in most of the time of the year, the backshore parts remain dry. The backshore part becomes wet only during high energy conditions, when storm or other kinds of high energy waves or currents came and inundate these areas. But in rest of the time of the year, this backshore part remains dry. So these are the areas mostly affected by aeolian activity, and due to this we found the sand deposit in these backshore areas. They are relatively more sorted compared to foreshore areas, and they almost always remain dry. And in most cases, these sand deposits of backshore areas, they show a general inclination towards the inland part. So there is you can see a distinct inclination difference between the backshore part and the foreshore part. And these backshore and foreshore part are divided by this raised area, which is the sediments deposited in the foreshore areas, and then they are pushed to the barm areas, pushed to the junction between foreshore and backshore and form these kinds of barm. But often it may also happen that during high energy conditions, the sediments deposited in the foreshore areas, they are pushed further landward and deposited beyond backshore areas in these portions. And later, the sediments in this barm or these backshore areas, they are also affected by the local wind activity also. And as we know that in coastal areas, most of the aeolian activity or most of the wind flow is from the marine part to the land part. So mostly wind blows in this way, in this direction. So the sediments, the dry sediments, mainly in the backshore areas, they are moving towards the inland part, or they are pushed towards the inland part. So beyond the backshore areas, sometimes the sediments accumulated and formed this type of accumulated landforms, which are known as coastal dunes. So coastal dunes form where the beach is wide. That means um, it allow the accumulation of windblown sand, uh, where prevailing onshore winds are dominant, and they push the backshore dry sand uh, to the inland part and form these kinds of highly raised landforms, which are often 10-meter high, and often they form complexes. So these are called dunes. And this formation of dunes is often depending on the coastal vegetation. As you can see in this picture also, that in the dune areas, there we found lots of plantation, and often it is occurred due to these kinds of raised landforms of sand are occur due to these plants, because the windblown particles from the backshore areas, they are trapped within this vegetation cover and form these kinds of elevated or raised landforms. Now, in this picture, you can see that is taken at the coastal areas of Odisha. Here you can see in this portion, in the extreme lower portion, you can see a sand deposition which is wet. That means the pore spaces within this sand, they are full of water. So this is the area which suffers regular tidal activity. So this zone is known as foreshore. In the upper part, you can see that there the inclination is also low, and the sand is dry. You can see a white color, and this is the zone which is which will be only inundated, or which will be only wet only in the high energy condition, only during the storm situation. Rest of the time of the year, as you can see, this portion remains dry, and this portion is mainly suffered aeolian activity. Beyond the backshore, in the far inland part, you can see these highly raised areas. These are the dunes, coastal dunes, and these coastal dunes often moves due to the aeolian activity, and depending on the vegetation or depending on the local water table, uh, towards the inland areas, because these are the wind blown in those areas is mainly from um, ocean towards the land. Next type of depositional landforms is known as spits. Now, a spit is a extended stretch of sand which is found in the sea from the land. Now, these kinds of landforms occur when there is a change in shape of the landscape, or the area suffers any kinds of obstruction, due to which the longshore uh, drifts or longshore currents or the reef currents face restriction. And due to this restriction, these currents will go on deposition of the sediments. So here is a simple process how spits formed. Sediments are carried by the longshore drift parallel to the shoreline. When there is a change in the shape of the coastline, and thereby it suffers any kinds of restriction, then deposition occurs. A hooked end form if there is a change in wind direction. So often this portion, you can see that the landward part or the beach part is extended here, and if there is a change of direction, so in the frontal part of this extended portion, often we can see a bending, and waves cannot get past over these land areas. They are restricted, and therefore the water behind the spit is very much sheltered, it very much restricted, and often forms this kind of marshy or restricted water body. So during high energy condition, the waves pass this restriction, that is the speed, and moves in the inland part, which is a depressed part, and often it is also inundated, or the water supplied from rivers also. But this water which moves in these areas, they becomes trapped because of this speed. They are not able to uh, move towards the offshore region. So this forms a muddy areas, a low energy condition where the water is almost stagnant, and often it forms some marshy landmass. These are uh, known as mud flats also. So speeds are formed mainly due to longshore drift, and these are the deposited materials which faces any kinds of restriction, and there may be different orientation of speeds or these kinds of depositional landforms. Now, Tombolo is a kind of speed which is a also a depositional landform, and it forms when an island is attached to the mainland by a narrow piece of land. So this portion is basically a speed which mainly forms due to the longshore current, and here there it face the longshore current face some kinds of restriction because of the elevated little elevated portion, and due to this elevated portion deposition occurs here, and that deposition connects the mainland with this island mass. So when this type of connection occurs from mainland to the island due to this speed, they are known as tombolo. The third one, or the third type of deposition found in the coastal areas, that is known as barrier or bar. Now, coastal bars, they are the products, or they formed due to some aggradation or due to some deposition of sediment, and their formation, morphology, and behavior are governed by the activity of wave, current, tide, local slope, and sediment grain size. So the any kinds of landforms formed in the coastal areas, they are mainly guided by all these factors. Now, when we found a raised area due to the change in topography, uh, and this raised area is submerged, now any kinds of flow, say for example in this raised area, if wave passed, so that wave is somehow restricted. That wave is not freely affected all the portions of this bottom substrate due to this slightly raised area at these portions. But this portion of the raised area, as you can see in this picture, so this portion is the raised area is submerged in water. So these restricted submerged portions within the ocean body, uh, within the coastal area, are known as bar. So bar is a restriction which formed due to any kinds of due to any kinds of restriction, and thereby deposition occurs and increasing its height, increasing its area, but always the bar is submerged under water. Now, when with prolonged time of deposition and thereby increase its height and surface area, when these bars is exposed into the atmosphere, exposed into the air, and forms these kinds of raised portion, that is called barrier. Now, the marine processes, that is the wave and tides at this condition, is not able to overcome this restriction and inundate these areas. So thereby, in the landward part of this restriction, which is known as barrier, or often it is called barrier island, they form a restricted water body which is mainly formed by due to this barrier island, and the supply of water or sediment in this portion is very much restricted. So this portion, or this restricted coastal body of water which have very limited connection to the open ocean is known as lagoon. Now, why this is they have limited connection to the open ocean? Because in the frontal part, in the offshore part of this lagoon, there forms a barrier island, or often it is also called as barrier bar. So because of this raised area, because of this barrier, marine water is not able to overcome this lagoon. Only in the exceptional situation, only in high energy condition, the lagoon gets fresh salty water, fresh marine water from the open ocean. Rest of the time of the year, the lagoon is very calm, stagnant condition, and it may gets its water from the landward part, that is from the when if any river or streamlets meets with the lagoon. So most of the time the lagoon uh, receives fresh water, but occasionally it will also intake the salty marine water. So that is why these are the called lagoons. Now the difference between lagoon and lake is always composed of fresh sweet water, whereas in lagoon these are mainly occurs in the coastal areas where it receives water from the stream or any kinds of rivers, that is the sweet water, but occasionally it receives water from the open oceans, and that water is salty. So it has, although limited, but occasional supply of salty water from the marine part. So it's a mixed water composed of both fresh water, fresh sweet water, and salty ocean water. That is why it is named with a different name and called lagoon. And always these kinds of lagoons are formed near the coastal areas. So these lagoons are formed due to any kind of restriction, due to any kind of bar or barrier island. Now here you can see in this picture that it is basically starting with a spit from these. It's basically a bay that is formed due to differential erosion. So must be these areas rock mass is composed of soft rock mass. So erosion is more pronounced here compared to these areas. Now, in this bay, firstly, they are formed from these beach areas a spit. So, in this spit, as you can see, when the waves came uh, to these coastal areas, then there will form a wave refraction. So, different parts of the wave hit at different time. Now, due to this there is a elevation difference in the coastal area. So this portion, the beach area, starts increasing from the two sides of the bay. So speeds are forming, or often it is called a paired speed that forms from both the side of the bay. So speeds are forming from both the sides of the bay, and with time these speeds start increasing their size, and after some time these beads are merged with each other and form these kinds of narrow states or narrow landmass. Now this landmass acts as a barrier which restricts the supply of water in this bay portion, in this uh, closed water body. and thereby formed lagoons. So previously it was a bay. Due to the formation of speeds and increasing the size of speeds, gradually with time these speeds merged with each other, so thereby closed the supply of fresh uh, ocean water to this part of the water body, and now this part is mainly feed from the inland fresh water, but occasionally in high energy condition it receives salty water from the ocean part. So that is why it's formed a lagoon, which was previously an old bay. Now there are some smaller terminologies which we commonly used, um, but these are not a prominent uh, major landforms. Firstly, there is peninsula, which is a piece of land mass surrounded by water on all sides except one. Actually, these are not any kinds of depositional landform. Rather, we can explain them some kinds of topographical features formed in the coastal areas. So first is the peninsula, which is surrounded in all sides by the marine water except one. So except one side, this landmass is connected with the mainland areas. Say for example, you may often heard the term Indian Peninsula. So if you look at the southern part of Indian landmass, that is surrounded in all sides by ocean water except in the northern part. So that is why it is known as Indian Peninsula. The second type is known as island, which is a landmass surrounded completely by marine water in all sides. And most commonly, these are not very large in size. So these kinds of landmass are known as island. And often or sometimes it is found that instead of a single large piece of landmass occurring in the sea, there is a group of islands found to occur within the sea, and these are individual small isolated landmass surrounded in all sides by marine water, but they are far smaller in size and they occur in clusters. So in that cases, the cluster of these islands is known as archipelago. One famous example is the Andaman Islands. That is also an archipelago. It composed of various or numerous small islands. So that's all. That's a brief introduction of the coastal processes and the landforms formed due to different types of coastal processes. Hope this will help you. Thank you.